Antiderivatives. So motivation, I have on here just some questions that would generate a reason to do antiderivatives. If I'm talking about, for example, we've talked a lot about, position and velocity and acceleration, and we always started with the position and then got your velocity from that and got your acceleration from that. But what if you don't know the position? What if you know the velocity? You know the speed that it's traveling? Wouldn't it be useful to find the position at a given time? If we shoot a rocket, we can know what speed it's going, but don't we need to know where it's going to be at a given point in time? So sometimes you start with that velocity and you have to go backwards to get your position. Or, think about like when there's an oil tanker in the ocean that crashes, okay, and you have oil leaking out. You might know the rate that oil is coming out of the tank. Don't we need to know how much oil has leaked into the ocean at a given point in time for cleanup purposes? So sometimes we don't necessarily know the amounts, but we know the rate. Or you might know the rate that a bacteria population is increasing, and you want to know what the population size will be at a given point in time. Or we might know the rate that COVID is spreading, and we want to know how many people would be infected at a given point in time. So all of these involve antiderivatives. In general, we use like f prime for a derivative. A lot of times, the antiderivative, we just use a capital F. And so capital F means antiderivative, and it's essentially the reverse. If you take the derivative of that, you get your original function. So it's saying you're looking at the derivative, what was the function that had that derivative? For example, I want to find the antiderivative of x squared. So I want to know what would be the original function, antiderivative is capital F, so that when you do its derivative, you get x squared for an answer. What do we think?
1/3 x cubed.
All right. When you do a derivative, you subtract 1 from the power, right? So if we're going backwards, we would add 1 to the power. So we know it has to have been an x cubed. But think about what happens when you do that derivative. You bring that 3 down in front. So I need something there to cancel it out. 1/3 times 3 would cancel. So it's 1/3 x cubed. Now that's not the only possible derivative. What is the derivative of 1/3 x cubed plus 4? It's x squared. What if I said 1/3 x cubed minus 7? It's x squared. If I said 1/3 x cubed plus pi, its derivative is x squared. So there are multiple antiderivatives. What do those differ by? What's the only difference? The constant. Because when you do the derivative, the constant disappears. It becomes 0. So, in general, when we find antiderivatives, we will put a plus c on the end to say it could be any constant there. So that is your next slide. The most general antiderivative would be f of x plus c, meaning you could have any constant on the end. There's a graph on the following slide, just shows the graphs of all the different antiderivatives of x squared. It's the same general shape. The constant just moves your graph up or down. But the slope of the tangent line is the same. That's why they have the same derivative. Okay, let's find antiderivatives for a bunch of these. Part A. So capital F for antiderivative. What function has the derivative of sine? Okay. Derivative of cosine is negative sine. So I would have to make this a negative cosine. What else do I need with that? Plus c. The nice thing is you can easily check your work on these guys. These are all going to be basic derivatives, So easy ones, you can quickly do the derivative of your answer and see if you get sine x. Alright, B. My antiderivative of 1 over x. What has a derivative that is equal to 1 over x? Natural log, good. And don't forget the plus c. C, f of x equals x to the n. So I'm basically coming up with a general form for x to any power. So when we do that antiderivative, a derivative subtracts 1 from the power. So the antiderivative will add 1. And then we always just have to multiply by the reciprocal out in front. So it'd be 1 over n plus 1 times x to the n plus 1. And don't forget the plus c. Any questions so far? I put a table in here that's in your textbook. It has all of these common functions and what their antiderivative is. I put it in here since it's in the book, but it's not really something that we need to sit down and memorize because we are really good with our derivatives, so we can think backwards from those. Alright, let's keep practicing. So we have x cubed plus 3 square root of x minus 4 over x squared. It can be useful, just like when we did the derivative. We usually rewrote it so we didn't have the radicals or x's on the bottom, right? So we're going to do the same thing when we do the antiderivative. 3 radical x would be 3x to the 1/2 minus 4 over x squared is 4x to the negative 2. So we are just going to do term by term. You're going to add 1 to the power and multiply by the reciprocal. So x cubed becomes x to the 4th, and it gets a 1/4 in front. Plus. Okay, we have not done any yet that have a coefficient. You'll get to where you're more comfortable with those. For now, I'm just going to just keep that coefficient. Just like when we did the derivative, coefficients just trail along. Same thing when we do the antiderivative. And then let's do the antiderivative of this x to the 1/2. So if you add 1 to the power, that becomes x to the 3/2, and then you put what in front? 2/3, the reciprocal of your power. Minus my 4 is just going to trail. Okay, x to the negative 2. If I add 1 to the power, I get x to the negative 1. So what do I put in front? Negative 1. Reciprocal of negative 1 is negative 1. And then, of course, we have to have plus c. So we can clean this up just a tad. So we get 1/4 x to the 4th plus 3 times 2/3 is just a 2. X to the 3/2. Negative 4 times negative 1 is positive 4x to the negative 1 plus c. And you can easily check. If I did this derivative, 4 come down, 4 and 1/4 cancel, and get x cubed. Bring down the 3/2, I get 3x to the 1/2. Negative 4x to the negative 2. And when you do the derivative of the constant, it disappears. Okay, I would like for you guys to try example 3. So you have x to the 5/2 minus 5 over x to the 4th minus the square root of x. how would you rewrite 5 over x to the 4th? And how do you rewrite the square root of x? Oh. So for my antiderivative, I'm going to add 1 from the power. So 5 halves plus 1 is 7 halves. You put the reciprocal in front, so 2 sevenths. Minus 5, and then let's do the antiderivative of the x to the negative 4. So if you add 1 to the power, that's negative 3. So we put a negative 1/3 in front. Minus x to the 1 half. If you add 1, 3 halves, so you put 2/3 in front. And we have to have plus c on the end. So our function is 2 sevenths x to the 7 halves plus 5/3 x to the negative 3 minus 2/3 x to the 3 halves plus c. Let's do some trig functions. When we do this, think about the coefficient is just going to stay for a moment. I'm going to do the antiderivative of this cosine 3t. When you do a derivative of a trig function, does the angle change? No. So the same thing when I do the antiderivative, it will still be a 3t. What has a derivative of cosine? Sine. So it would have a sine 3t. Now think about this. When you did the derivative of sine 3t, you would keep the sine would become a cosine, angle stays the same, but then what would you do? You do the chain rule, times the derivative of the angle. What is the derivative of 3t? 3. So what do I need to cancel that out? 1/3. So we have to think about, if we're applying the chain rule, we need to put something to cancel out that number. We need the reciprocal. Okay, let's talk about this one. The 5, let's just hang on to that for a second. What has a derivative of sine? Okay. The derivative of cosine is negative sine. Since I want a positive sign, I would have to put a negative here. The angle would stay the same. But then you would have to take it times the derivative of 4t, which is 4. So what do I need to put in front of this? A 1/4 to cancel that. Does everybody see where I got my 1/3 and 1/4 from? So 2/3 sine of 3t minus 5/4 cosine 4t plus c. Again, if you're not sure, what do? Do the derivative and check it. If I were doing the derivative of this, derivative of sine is cosine, angle stays the same, times the derivative of the inside. Derivative of cosine is negative sine, angle stays the same, times the derivative of the angle. Derivative of the constant is 0. 2/3 times 3 gives me the 2 cosine 3t. Negative 5/4 times a negative 4, and we get that. So easy to check these. Just do your derivatives. Okay, so a very similar one. I want you guys to try this one. Remember, pi is just like any other number. So the antiderivative of cosine would just be a sine. Pi x stays, so we have to have a 1/pi. Antiderivative of sine is negative cosine. The pi x stays, but you need a 1/pi. So you should get 2/pi sine of pi x minus 3/pi cosine of pi x plus c. keep looking at these. So sometimes when we're doing these antiderivatives, we have to think about how we would do the derivative. If you had an x plus 5 to the 10th, would you multiply it out 10 times? No, we would do the chain rule. So when we're doing our antiderivative, we have to think about the chain rule. When you do the chain rule, the inside doesn't change. So the inside is not going to change here. It's still an x plus 5. What do we do to the exponent? Add 1, so it's an 11, which means I need what in front? 1 over 11. Okay, when you do this derivative, the 11 comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside. The derivative of x plus 5 is just 1. So do I need to put anything to cancel that? No, we don't have to worry about it on this problem. But what else do I need? Plus c. The next one. 1 over 3z plus 10 to the 7th. How might we rewrite that? So the antiderivative, inside stays the same. Add 1 to your power, -6, so I need a -1/6 in front. Now think about this derivative. The -6 comes down, inside stays the same, subtract 1, times the derivative of the inside. What is the derivative of the inside? 3. So what do I have to put to cancel that? 1/3. So if I multiply my -6 and my 1/3, I get -1 over 18 times 3z plus 10 to the -6 plus c. Look at this. What would you recommend I do to start? Okay, can we simplify this? Because I don't know about you, but I do not want to attempt to do a quotient rule in reverse. Okay, we need to rewrite these without products or quotients, if at all possible. It is really, really, really difficult to work backwards from a product or a quotient. But if I just rewrite this, I said g prime of x equals 4 sine of x. 2x to the 5th over x would be 2x to the 4th minus, this is x to the 1/2 over x. What would that give us? X to the -1/2. So if you have a quotient, as long as it's just one term on the bottom, you can split it up and divide each thing. So now our antiderivative, we have a 4 antiderivative of sine is negative cosine. 2, okay, x to the 4th. So if you add 1 to your power, you get x to the 5th, which means you need the 1/5 in front, minus x to the -1/2. If you add 1 to your power, you get positive 1/2. So what do we need in front? 2. And then never forget your plus c. So we have -4 cosine x plus 2/5 x to the 5th minus 2x to the 1/2 couple more examples, and then I'm probably going to stop for today. Why don't you guys do this one? Is that on your handout?
It has the first part, but then it doesn't have the equal to
Oh.
that.
So do you get 5x to the 4th minus 4x cubed plus 3x squared plus c? Very easy to check that one. I'm going to skip for a minute, I think. I want to jump down to example 12, actually. Okay, this one is slightly different because I am giving you a point on the original function. What I'm doing is giving you the information to find the constant value on this particular problem. So we're not going to have a plus c, we're going to have plus a number at the end. It starts the same way with the antiderivative. Now I would probably rewrite, I said f prime was x to the 4th minus 3x. Instead of 3 over x cubed, that would be 3x to the negative 3. So if we do our antiderivative, x to the 4th, if you add 1, that's an x to the 5th, so it gets a 1/5 in front. Minus 3, okay, this is x to the 1st, so if you add 1, it's x squared, so it gets a 1/2. Plus 3x to the negative 3. If you add 1, that's negative 2. So it gets a negative 1/2 in front. Plus c. You can choose, you can leave this as like a 3/2 x to the negative 2. Sometimes you might see me rewrite it as like a 3 over a negative exponent. We'll put it on the bottom, 2x squared. In general, I don't care. So just know that it can be written either way. So here is my antiderivative. But then I told you f of 1 equals negative 1. So if I plug in a 1 for all of my x's, I get 1/5 times 1 to the 5th, so 1/5. 3/2 times 1 squared is 3/2. Minus 3 over 2 times 1 would be 3/2 plus c. And this all has to equal negative 1. Okay, so if I combine like terms, this is like 2 over 10. So if I add that over, my c value is 3 over 10. Is that right? You guys checking my math at all? Or you just want to go with it? You believe me? Hold on, I think I might have made a mistake. I don't think I subtracted my second 3/2. You guys should check me. You can't trust me. I dropped a 3/2. So what should this really come out to be? Right here? This is negative 14/5. Right? And then if you add that over, you get your 9/5. So my final equation, my function is 1/5 x to the 5th minus 3 halves x squared minus 3 over 2x squared plus 9/5. So we will do more of those next week where we're actually finding the constant value. None of your homework tonight will have those, but I just wanted to touch on one. Okay, so that is our stopping point homework, and I'm trying to give you time in class to do this right now because there's a lot going on this weekend. 1 through 17 odd. And you've got a little over 10 minutes to work on that